All right, so when we're solving 4 to the x equals 5, this is what we need to think how Taylor was just thinking about this, like what exponent to this. So one way to do this is when the exponent stuff can't work, try rewriting the equation in logarithmic form, okay? So if I rewrote this as a logarithm equation, I would put a log in. What would be the base of the log? 4. Then I have to figure out what goes in here and what's the answer to the log problem. So what goes in here? 5. And then the exponent is what ends up here. So this actually looks better if I could actually calculate this right here. It's at least all numerical, right? So there's got to be a way I can like plug that into a calculator or something, okay? This is a value. So this is what x is worth, log base 4 of 5, okay? If this was a non-calculator thing, which your test may be non-calculator, so you might just have to stop at that point, then this is what you would leave. X could be equal to log base 4 of 5. That's fine. Okay? Now, how we enter this into the calculator. Some calculators have a way for you to enter the base that you want and enter the number you want, and you can continue that way. But some of them don't. So we're going to talk about how we enter it into a calculator that doesn't have that. So some of you might recall in Algebra 2, to solve this, they said, well, take the log of both sides of the equation. Does anybody remember them saying that? Yeah? Okay. So when you take the log of both sides of the equation, this is why they said to do that. And we'll see how this is the same as the other in a minute. Now notice I wrote a log without any base. And there's a button on your calculator that says log, and it doesn't have any base next to it. That doesn't mean you get to type in whatever base you want. That logarithm has an assigned base that is so common that we just don't write it. Okay? And so they call it the common logarithm. When we write the word log and we don't write the number base next to it, does anybody know what number they're using? 10. Okay? Because our whole number system is based on like powers of 10, so they just kind of assume that could be a common thing for us. So when we write it like this, though, then there is a button automatically on the calculator for it, right? That log button. That means log base 10. Now, why we want to do this, there's a log property that says if you're taking a logarithm and in your logarithm there's a power, that's the same as this exponent coming out in front and multiplying the logarithm. And the reason that would even be somewhat helpful is because now you have x being multiplied by some number equal to some other number, even though these numbers look different than what we're used to seeing. And then all we have to do at that point is divide by the number that we want to cancel off. So this means x is equal to log of 5 divided by log of 4. Now remember, these logs look like they don't have a base, but they really have a base of 10. So you can actually type this into the calculator right now. The way you can type it into the calculator is by typing log, and then it should give you parentheses or something. It'll say of 5, and divided by log of 4. Okay. And then you should get 1.16. So we get 1.16. Okay. Now, you might think, well, that's not the same. Like, I got this. That's not the same as this. But it actually is. There is a formula called the change of base formula. Because a lot of calculators don't have a way for you to put a base in, they had to come up with a way for you to calculate this in the calculator. And you literally would put this into the calculator by doing common log, log base 10, of the number that you're taking the log of, and you would divide it by the logarithm of the number you're using for the base. Notice that that's the same calculation that we did over there. Okay? So non-calculator, you could leave your response like this, or you could leave your response like this. Those are the same. Okay? Calculator-wise, then, you should be able to type it in from either version like this and get this response of 1.16. Does that make sense? All right, little review of how to solve them. The reason we're reviewing this is I'm going to start asking you for x-intercepts and y-intercepts of equations that have logs and exponents in there. So you're going to have to solve a lot of exponential equations and a lot of logarithmic equations, and they're not all going to be nice like this when you plug it in, right? If they work out nice like this, great. We can set the bases equal. But if they don't, then we have to have this other method to use the logarithms. All So looking at part E up there. So the first thing you would ask is, can you write both sides of that equation using the same base? I don't even know much about 823, but I'm guessing that it's not a power of 5 considering it ends in 3. Okay, so I don't think that I can write those with the same power. So then I'm going to want to go through the process I went through before. So I can take the log of both sides. Remember, the purpose in us doing that is it kind of releases the exponent. Okay, the log property says, all right, then the exponent, this is the same as having the exponent multiply this logarithm. So to solve this, here's x. It's being multiplied by a couple of things. It's being multiplied by 3, and it's being multiplied by this other number that I don't know what it is, except for that it's a log of 5. So I can divide by both of those quantities. I just have to be careful if I go to put this in my calculator. So here, so if it was non-calculator, we'll just leave the answer like this. Okay? Saying, yeah, I know you can solve it. Here's what you get. I just don't know what number that is exactly. If it's calculator, then we're going to go put this into your calculator. But I'll give you a small warning. One, make sure that you don't accidentally include the 3 inside any of your logarithms. So when you go to type this in, if it gives you a parentheses, after you type in 823, close that parentheses because you don't want that next 3 to be part of that logarithm. Second warning, if you type the denominator in without parentheses, depending sometimes on the calculator or whatever, it may think you're dividing by 3 and then you're multiplying by log of 5. But you want 3 and log of 5 to all be doing dividing in this problem. So if you ever have more than one thing in the denominator and you want to make sure the calculator understands what you mean, you'd want to put your whole entire denominator in parentheses so the calculator knows what that looked like as part of the equation that you were solving. Okay? So go ahead and put it in the calculator so you can make sure that you're getting the right number. And I'll do the same. So you should, in this case, get 1.39. So that would be your decimal answer, or with a non-calculator, you would just leave all the logarithms written out in your answer. Okay? All right, questions about this?